In this lesson, we will write a class which is responsible for binding data and listeners to our XML layout. This is what we typically refer to as a view in the standard architectures such as Model View Presenter, Model View View Model, and so forth. Now, be forewarned that in an application more complex than this, I would typically use fragments instead of activities as the views, and very often what I'll do is I'll try to only have one or maybe two activities if I really need to for an entire application. Really, that just depends on how much tight coupling to activities that the particular application I'm building happens to have. Sometimes you need to use an activity for things like Google Maps API and so forth. Anyways, to keep things simple today, we will use an activity as our view, and we will take advantage of the onSaveInstanceState function in order to temporarily store the state of the user interface. Now, before we get to doing that, just as we built the interfaces for the middle and back end of this application, we're actually going to build a front-end contract interface. I just like to use the word contract out of habit, but it doesn't really mean anything in particular. But we're going to build an interface for the front-end components of the application. So again, normally I would build one of these contract classes for every feature in an application. In this particular case, we only have one feature, so that's what we'll be building it for. But it will include an interface for both the view and the logic class, which we'll talk about later. Now, the reason why we'll be building this interface is that it will do two different things for us, a couple different things, but in particular, it will allow us to build these different components independently of each other, in isolation of each other, and it'll also make writing tests for the logic class much easier. Now, you may be wondering, are we going to be using Espresso to test the activity or something like that? Well, we actually aren't going to do that. We're going to use a particular style of architecture known as passive view. So basically what's going to happen is that we are going to drastically simplify the functions in the activity or the view and basically pull all of the presentation logic, or as much as we can, out of that view and into our logic class, and then we will basically apply test-driven development to the logic class. So in a sense, we're still kind of indirectly testing the view. At the very least, it's going to be so simple to write that we basically don't need to test it. So with that, let's jump into Android Studio and work on the contract. All right, so first thing, we are going to make a new package in the main package, and it's going to be called user interface. I'm giving these things super long names just so they're really easy for everyone to know what's going on. And within that particular package, we're going to right-click, go to New Kotlin file or class, and this one I'm going to call it iCalculatorUI. So it's basically going to be a contract for the front end of this particular feature of the application, as discussed earlier. So we're going to have a couple different things here. It won't just be an interface, but as we'll see, the things that I'll be putting in here kind of all tie together, and they all have to do with the front end. So the first thing we'll have is we're going to type interface iCalculatorUI. And then to make things kind of organized easily, we're going to create two child interfaces. So one of them is going to be called view, and these are pretty self-explanatory what they represent. For view, we're going to have basically an interface property called display, and that will represent, of course, the display of the calculator, and this is how we will both get and set the display. And we're also going to have a function called showError, which will accept a string. And what's going to happen there is it's just going to display the error via a toast. We're also going to have an interface called logic, which if you've been following this course in order, you should have a rough idea of what this logic word means in this case. It means the presentation logic, the front-end logic. And this particular class is going to have two functions. The first one is going to be fun handle view event, and it's going to accept a class of type view event, which we'll build in a minute. You can just leave that. And it's also going to have another function which is going to be called handle result. Now the view isn't actually going to be calling this particular function, so actually normally what I would do here is I would make a separate abstract class to include this function. I do want every logic class to include it, and I didn't want to just have a class explosion here, so that's why I'm including it here. We'll see how this works kind of later on. We're actually going to be passing this function via function references into the back end of the application to handle a result. Anyways, just bear with me. We're going to have it accept a result, which is going to be of type result wrapper. And for generics, it's of course always going to be exception. And then it's going to be a string. So that's all we need to do for that. So outside of the parent interface brackets here, we're just going to add in a const val, which will just represent a generic error message. If you are basically making your application so that you want it to support many different languages, of course this isn't what you would want to do. It would be better to do that via string values. In this particular case, we're not interested in supporting different languages, so it's just really easy and quite efficient to just use a const val. We're going to call this thing, let me just zoom in a little for you, generic error message, and the actual text is just going to say invalid expression, just like so. So we're almost done here. The only other thing we need to do is we want to basically create a sealed class to represent the different potential events which could occur in this particular feature of the application. Again, if I had multiple features, I would have one of these interfaces for each feature, and I would have one of these sealed classes for each feature. So obviously in this case we only have the one. So we're going to create a sealed class called ViewEvent. And within that sealed class, we're going to create a couple different things. So we're going to have an event called evaluate. And if you recall from earlier lessons, hopefully I talked about it, but in this particular case, if there's no value we really need out of the child class, then we can just use an object, and we can use data classes if we do need a particular value. So I'm just going to click beside this one and hit Control D twice. The other event is going to be called delete, and then we have delete all, and we'll see how those kind of work in a minute. And then we're going to have a data class called input. So this will be when the user hits a character, pretty much anything other than the delete button and the equals button, and it's going to possess a string called input, and of course we have to make that extend view event. So that's all we need to do for our contract class. What we'll do next is we'll work on the activity. Okay, so go ahead and open up main activity. And the first thing I'm going to do is I'm just going to double click to select the name here, the class declaration. And I'm going to hit Shift F6. And then I'm going to type calculator activity. Then I'll hit Tab. And what that's done is it's just renamed both the file and the class to calculator activity. Always be sure that your activity or your set content view is pointing to the appropriate layout. Since it's automatically generated, we're totally fine here. So what we're going to do is we're going to write this class out and pretty much get everything configured the way we want. How we're going to be actually binding to the views is we're going to need to use Kotlin synthetic properties. Now, if you followed the instructions in the video where we set up Gradle, there's of course the Kotlin Android extensions plugin. If you're not able to use Kotlin synthetic plugin or Kotlin synthetic properties, as we will in a minute, probably you messed something up in Gradle, so just make sure that's included. Anyways, how this is going to work is we're going to actually import a reference to our user interface. So I'll just type the whole thing out. So we're going to type import kotlinx.android.synthetic.main. And then we include the particular layout which we want to refer to. And then we're going to hit .asterisk. So in case you're not aware, when you see an asterisk in an import statement, what this basically means is import everything from within this particular package or directory or whatever you want to call it. So that's all that means. So basically what we've done here is we've imported pretty much the whole view hierarchy of that particular layout, which of course matches the set content view layout down here. So now that that's done, we're just going to add a couple different interfaces. So the first interface we're going to add, I'm just going to hit Control-Alt-L to kind of, here, let's do that in a minute. The first couple interfaces I'll be adding is we're going to have view.onClickListener to handle click events. Go ahead and import that. We're going to have view.onLongClickListener. And then we're also going to have iCalculatorUI.view. So that's, of course, the interface we wrote. Now, the reason why we have this on long click listener is that when the user long clicks the delete button, I want it to completely clear the display. So that's why we have that there. So I'm going to again hit Control-Alt-L. Hopefully it'll look a little better. That's better. And what we'll do next is this thing is showing up red because we need to import the appropriate interface functions. So I'm just going to click here on the red text, hit Alt-Enter, and then hit Implement Members. I'm going to make sure I select everything here, and then I'll hit OK. So just as a small kind of organizational step here, I'm just going to make a Java comment here, or Kotlin comment, I guess you could call it. Interface functions, and that's just like a visual separator to indicate where the overridden functions are going to show up. That won't include onCreate in this particular case, or the Android inheritance functions. This is just the interface functions. This is totally optional just for organizational purposes and legibility. So anyways, before we get to that, there's a couple other things we're going to add. So the first thing is this particular class is going to interact with naturally the logic class which we wrote here. Now we haven't created that, but again, because we're using interfaces, we can still basically build it, except we'll just reference the interface itself. If that doesn't make sense, just follow along here. So we're going to type late init var. So late init basically means this thing won't be created immediately. We will create it later on, and I'll talk about that in a minute. And this thing's going to be called logic, and it will be of type iCalculatorUI.logic, like so. And that's all we need to do there. So what we're going to do, you might be wondering how we're going to create this class. So we're actually going to use some handwritten dependency injection, which will be super simple. But we're not going to do that until just about the last video in this particular section. So what we're going to do instead is we're just going to type to-do, and we're just going to type in here create dependency, or actually let's say implement dependency injection class for logic. Anyways, moving on, what we can do is finish off the rest of this class. So what we're going to do is we're going to type bind user interface brackets, and this is going to be a function that we create. This is a helper function. Whenever you're building all these kinds of functions, you want to try as much as possible to use helper functions because it makes things more organized and more legible. So I'm going to click on this, hit Alt-Enter, and then create function, not abstract function, bind user interface down here. So what kind of code are we going to see in bind user interface? We are going to see all of the different on-click listeners for all of the widgets which are present in our UI. Now, since we gave everything good names, this will be a little bit tedious, but it should be pretty easy to write. So let's get started. We're going to need btn evaluate. So you might be wondering, okay, what's going on here? How come we can just type the name of an XML view? Again, this is exactly because we're using Kotlin synthetic properties. There's no find view by ID code. All we have to do is import the proper layout, and we can refer to things immediately. So really a big fan of Kotlin synthetic properties. Anyways, so we've got btn evaluate, and we want to set an on-click listener. And what we'll do is for all of these different calls, we're going to have obviously our activity handle the events. So we're just going to type this for all of them. Next, what I'm going to do is I'm just going to hit Control D twice. The next one's going to be btn decimal. Next one will be btn delete. And then I'm going to hit Control D on that one, and then we're going to go set on long click listener. This. Okay, that's the first ones. Now we need to do all of our number buttons. So what I'm going to do there is I'm going to hit Control-Z, Control-V, and I'm going to basically add this in for the 10 different numbers that we have, obviously including 0. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hopefully I can count properly, but there's no guarantee there. We're going to say button 1, button 2, button 3. Oh, this is so exciting. Button 4. Oops, that's not what I wanted to do. Button 5. Button 6. You probably get the idea. And 0. Okay, but we are not done because obviously we'll also need to add listeners to our operator buttons. So that's going to be button add. Actually, I'm kind of doing this in a silly way. Let's just copy that. Control paste 4 times. So that'll be button add, button subtract, button multiply, and button, let's see if I can get this correct here, button divide. Oh, that didn't turn out so well. Okay, so those are all of the different functions. Now, since we're not going to be testing this thing using espresso, we do want to just double check to make sure everything here is correct. So I'm just going to visually look and make sure I haven't screwed anything up. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Add, subtract, multiply, divide. These are all on click listener. That's good. We've got evaluate, decimal, delete, and delete on long click listener. So that should be everything we need there. And the next thing we'll do is we'll actually implement our on click listeners. Okay, so the first one we'll implement is the easier one, the on long click listener. So I'm just going to rename this to V because PO is not very legible. In any case, what we're going to do is we're going to type here, so when v.id, and we're going to use the nullable operator there. So this won't be evaluated if v happens to be null. Equals is essentially what we're saying, r.id.btn delete. So if it is the delete button, which was long clicked, and that's the only thing we've attached a long click listener to, so that will be the case, then we want to type logic.handle view event, and the event we want to provide is view event.delete all, and we just need to import that. There we go. And so it's still showing up as red because on long click returns a Boolean. So we're just going to type true in here, and what this means, it's not super easy to explain, but return true if we don't want the on click to be called next. So basically what we're saying here is if the user long clicks the delete button, we don't want to also call the on click function right after that. We only want it to call on click. It's a little confusing, but that's just kind of what you need to do. And I need to type a return statement there. That should fix that. So the next thing we'll implement is our onClick function. So I'm actually just going to copy paste this, copy, not cut, the when statement here. We'll rename that also to v. And so what we're going to have is, so if the ID is button evaluate, then we want to say view event evaluate. I'm going to hit Control D twice. So we also have the regular delete event or button, and that's going to be, of course, just delete. And then we have all of the different input buttons that could get pressed. So in that particular case, we're going to type else. And then we're going to say if v is a button. So we're just kind of using a little bit of selection here so that nothing too random happens, but you could probably skip this, to be honest. If v is a button, so we know a button was pressed, then we're going to type logic.handle view event. Then we're going to say view event dot input, and of course we need to actually give it the input. So what we'll type in there is we're going to say v.text.toString. So we're going to get the character of the particular button, and that's how we're actually going to basically pass off these input events to the logic class. So that's all we need to do for onClick here. The next thing we'll work on is our show error function. So this one's going to be super easy. We just type toast.makeText, supply this as the context. Value will be the message that we want to display, and then we need to supply a particular length. So we're going to use length short, and of course whenever you use the toasts, you need to make sure that you call show, otherwise they won't actually show up. Luckily there's a handy little lint check for you, but yeah, make sure you call show. Alright, so that's our show error function. The only thing left is to sort out our display. So again, this is going to refer to the text view display of our calculator object. So for our custom get function, we're going to type lbl display.text.toString. Now, because this is single expression syntax, we don't need to use a return function, a return expression, I guess I should say. And then we have this other one here, set value. So what we're going to do is within the generated block brackets here, we're going to type lbl display.text equals value. So again, this is going to function really just like a getter and setter if you're from other languages. It's just a little bit more concise, and I just wanted to show you how to use something like Kotlin extension property. So that is everything we need to do in this class, except of course when we come back to actually build our logic class properly. But we can't actually do that without configuring a bunch of other stuff, so we'll come back and do that towards the end. So yeah, that's basically it for this lesson, and this is how to use Kotlin synthetic properties. As you can see, they are pretty handy. Alright, I done goofed and forgot to include the onSave instance state implementation, so let's go ahead and implement that right now. So how this is going to work is we're going to need some kind of string constant, so we can say companion object val display state equals state. And the reason why we're using something within a companion object is that this is basically similar to a static variable in Java, and what that basically means is that this thing's going to be reserved in static memory space, and it's just going to be more efficient. Anyways, we're going to need to override two functions here. So the first one will be override fun on save instance state. Now, quick point about this, and this is something that screwed me up when I was actually putting this thing together. There's two different options here. One of them is let me just actually implement it here. One of them has this second parameter, out persistent state. I don't know what exactly this function is for, but it, at least for me, did not work at all and caused me very confusing errors because it wasn't getting called. So make sure you select the version of this function which does not have that out persistent state bundle, simply out state. And as you can see, that has cleared that up. This is the version of onSave instance state you want to be using. Now what we'll do in here is we're going to say out state, and we'll use the nullable save call operator, put string, and the name of the string will be display state. And the value will be lbl display.text.toString. Like so. So what we're doing, we're just grabbing whatever the current display state is and we're writing it to this out state bundle. And then the next thing we need to do is we need to say override fun, and this will be on restore instance state. And again, similar situation here, so we want to use the correct one. I just accidentally clicked on the wrong one. Let's just fix that. And there we go. And then what we need to do here is we're going to say lbl display.text equals saved instance state, if it exists, get string, and then we will supply display state, and if it doesn't exist, then we will just return an empty string there. Now, a couple things about this. I don't actually usually use onSave instance state in my applications. What I typically do is I will have a view model which stores the state between things like orientation changes. Again, I didn't want to load this project up with a bunch of different libraries and a bunch of different approaches, and for the purposes of what we're doing here, this will suffice absolutely fine.